Hello, I'm now going to explain about the importance of data normalization for training a KNN model. Here we will look at a very simple example. So my training data only has two points, two observations. So A and B, right? And there are two variables. Um, let me write it down. So P equals 2. There are two variables, x1 and x2. Um, at the point A, x1 is 0 and x2 is 1, and at the point B, um, x1 is 2 and x2 is 0. Right, so let us say that x1 is um, price something of whatever in cents, and x2 is going to be the distance, I don't know, maybe length, let's say distance in meters. It doesn't really matter, right? Okay, and we are going to train a KNN model with k equals 1, right? So which means that whatever the new observation comes, we're going to predict it with the value at the uh, response variable at the either A or B, whichever is nearest to this new observation, right? And let's say, I know, for the sake of an example, that the response variable at the point A is 10 and the response variable at the point B is 42, right? So they're going to be quite different. So now let's say again, so that the new observation is the origin 00x. Now currently um, A is closer to x than B, so which means that at the moment our prediction is going to be that y, the response variable at the new point, is going to be 10, so which is the same as um, for A, right? So I should write that y of x should be 10. Right, but what happens if we recalculate our data? So let's say if instead of the price in cents, let's say x1 is the price in dollars, right? So if x1 is the price in dollars, then it really means that the value of our price in dollars, to compute the price in dollars, we should take the price in cents and divide it by 100. And so which effectively means that our point B is changed to 0.020, right? And now if we re- recalculate the price to be in dollars, then the nearest point to x is now b rather than a, so which means that y of x should be, instead of 10, it should be 42. Right? So what I mean is that the rescaling um, the variables, it affects the very notion of which point is, of the distances between points, and which means that it affects the notion of a neighborhood of a point, and which ultimately uh, affects predictions. So, and basically, um, if our variables are measured on a very different scale, or like if one of the variables varies from, I don't know, 1 to 10, and another variable varies from 1000 to 1 billion, then of course, um, the first variable, which is smaller, is basically going to, well, the is going to have, well, in a sense, is going to have more effect, right? So because the distances that are smaller um, are going to ultimately affect the neighborhood of any new observation, and ultimately are going to affect predictions, right? So my point being is that if you rescale variables, then the predictions of a KNN model are going to be different. So, and as a rule of thumb, it is advisable to somehow change all the variables to so that they're measured kind of on the same scale. So we can standardize them or normalize them, or well, do some kind of similar transformation. Well, this is kind of in contrast with the linear model. So if you compare this with the linear model, right? So if you have a model y that looks like beta 0 plus beta 1 x1 plus beta 2 x2, and suppose that you rescaled x1 by dividing it by 100, right? So you have like a new x1 prime, which is x1, I don't know, tilde, which is x1 divided by 100. Then basically, in order to um, sort of um, make this change, you can just update beta 1 by multiplying it by 100, right? So it means that y is beta 0 plus 100 beta 1 times x1 over 100 plus beta 2 x2. So here I just multiplied and divided by 100, but if you call this like beta 1 tilde, then this is x1 tilde, right? So if you rescale any of the variables in a linear model, what actually happens is that it's just that when you train the model, you should sort of accordingly rescale the coefficients of the model, but the final result is not really going to change. Okay, so that's the why you shouldn't. I mean, you can, but you don't have to rescale variables to train a linear model, but you absolutely have to do it for a KNN model. I mean, at least you have to take this into consideration.